Okay, these are notes for 6.1b, which is exploring polygons. And many of these notes, it starts on page 402 in the book, and many of these notes are you're just going to copy right from the book. I'm not going to be able to write it all on here. So on page 402, make sure you're there, and look at the definition of a polygon, and we're going to write it here. So it starts out by saying it's a plane figure. So please write that. It's a plane figure whose sides are 3 or more coplanar segments, so the sides have to be segments, that intersect only at their endpoints, which are the vertices. So go ahead and keep writing this. A plane figure whose sides are 3 or more coplanar segments that intersect at their vertices, and also consecutive sides cannot be collinear, and no more than 2 sides can meet at any one vertex. Consecutive sides cannot be collinear, no more than 2 sides can meet at any one vertex. So in any polygon that we deal with, each of these is a vertex, and each of these is a side. And I need you also to put the definition of a diagonal in here. So please just add this. A diagonal, this is also in your book, a line segment whose endpoints are any two non-consecutive vertices of the polygon. So definitely pause this as often as you need to get all these definitions in. The diagonal, a line segment whose endpoints are any two non-consecutive vertices of the polygon. So, for example, these two. Okay, now we need to know the difference between convex polygons and concave polygons, which are going to be down here. So a convex polygon, somewhere, please write this definition, is one in which each diagonal is in the interior of the polygon. So to be a convex polygon, which is what we're going to be dealing with, the diagonals have to be completely on the inside of the polygon. So concave polygons, you're going to end up with a diagonal on the outside. So here are two non-consecutive vertices, and if I drew the diagonal between those two, it's completely on the outside, which is what makes it concave instead of convex. So all of these have diagonals that can be drawn on the outside. So these are all the concave, and these are all the convex that are going to have their diagonals all on the inside of the polygon. And then the ones down below that are not polygons at all, so they don't fit that original definition. So they do have to intersect all the endpoints. We can't have them crossing over like this. The endpoints, there can only be 2 endpoints meeting at any one vertice. This curved line is not a segment, so it makes it not a polygon. And this is trying to show you they're in 2 different planes, one standing straight up, one flat. Okay, again, you're going to use your book and you're going to fill in this chart. So you do have to memorize these names. Just go ahead and put me on pause and fill in the chart. So if it has 3 sides, it's a triangle, and go ahead and do them all. Quad, pent, hex. So you can just use the book and do that. And then when you get to n, it's an n-gon. You can go ahead and Google names for an 11-sided or a 12-sided figure, but really, most of the time, once it gets above 10, we just call it 11-gon, and a 12-gon, and 50-gon, 60-gon, whatever, as it gets higher, and so an n-gon. Now, on the next page, we're going to do this investigation with the sum of the interior angle. So we're going to start by taking these figures. If you have a three-sided figure, we're going to draw diagonals. We cannot draw diagonals that cross each other. So we're just going to draw diagonals. The triangle doesn't have any diagonals, so therefore the sum of its interior angles we know already is 180. With a quadrilateral, we could think of it this way: it has one diagonal and it separates it into two different triangles. So each triangle has a sum of 180, and so it would be, if we're finding out the sum of the interior angles, we can think that it has two triangles, and so it would be 2 times 180, or 360. For the pentagon, I'm going to draw two diagonals to separate it into 1, 2, 3 triangles. So it'd be 3 times 180, which is 540. The hexagon, 1, 2, 3, separates it into 4 triangles. 4 times 180 is 720. And I think you're seeing the pattern now. The 7-sided polygon is going to be separated into 5 triangles. It'll be 5 times 180. This will be 6. And so with n number of sides, you're going to separate it into n minus 2 triangles, and the sum of the interior angles is n minus 2 times 180. And this is the actual formula we're going to use to figure out how many sides, the sum of the interior angles according to the number of sides. So we just said that the sum of the interior angles of every quadrilateral is 360 degrees. The sum of the interior angles of a convex n-gon is n minus 2 times 180. So this is the formula we need, equals the sum of the interior angles. Sum of interior angles of any polygon, according to n being the number of sides. So we're going to use this formula. Find the sum of the interior angles of a convex 50gon. So we would go 50 minus 2 times 180. 48 times 180. The sum of the interior angles of that 50-sided figure would be 8640. Now this one's, number 2 is saying the sum of the interior angles is 6840. Find the number of sides. So I'm going to set the formula, n minus 2 times 180 equal to, so they're saying the sum of that figure is 6840. We want to figure out what n is. I'm going to divide both sides by 180, and I get n minus 2 equals 38, and n equals 40. So that tells me that was a 40-sided figure. It had 40 sides. Now, for number 3, we're going to be finding the value of x and then the measure of each angle in the following picture. So in order to do this one, I'm going to have to start by figuring out what x is by looking at this triangle. Since this is a 60-degree angle up here, this is 90, tells me this is 30. Now these 3 together are going to be 180. So I'm going to do x plus 65 plus 30 equals 180 to figure out that x is going to be 85. So that's angle BAD. Angle BAD is 85. So angle B is 85 minus 10. 75. Angle C is 85 plus 40, 125. To find angle D, I'm going to call angle D Y. And I'm going to add up these angles of this quadrilateral. So I've got 85 plus 75 plus 125 plus y. And the sum of the interior angles of that any quadrilateral is 360. So from this, go ahead and put it on pause and figure out y. So I believe I got y to be 80 degrees. So that last angle, angle C, DA, is 80 degrees. In the next problem, they're showing me that I have parallel lines. So in this quadrilateral, these are going to be same side interior angles. They all would add up to 360, so I could add them all up to 360, knowing that these others are 90. But I'm just going to go 3x minus 25 plus x plus 5 equals 180. It gives me 4x minus 20 equals 180. 4x equals 200, and x is 50. For the next one, I've got a pentagon. I'm going to do some of my work above. I've got a pentagon. I've got angle P is 60, pentagon PQRST. Angle P is 60, angle Q is 130. S and T are both 3 times as big as angle R, 3 times as large as angle R. So I'm going to do an equation that I'm going to say let angle R equal x, and so angle S is going to be 3x, and angle T is going to be 3x. And it's a pentagon, so when I add them all up, it's going to be 5 minus 2, the sum of all the interior angles, 5 minus 2 times 180, which is 3 times 180, which is going to be 540. So I've got 60 plus 130. Okay, now we're going to deal with the exterior angles of the polygon. And I'm going to start with a triangle. Say we have a triangle that has these angles, 70, 70, and 40. And we know they add up to 180. To draw exterior angles, I'm going to draw it like this. And we know this exterior angle is 180 minus 40. This one is 180 minus 70. And this also 180 minus 70. If we were to add these exterior angles together, we get 360. And the same thing is true, let's do it with a rectangle. We know the exterior angles interior are each 90, exterior are each 90, and the sum is also 360. Well, it happens to be true with every polygon. So if you take the picture here and add these up, 78 plus 77 plus 74 plus 84 plus 47, the sum is going to be 360, because the sum of the exterior angles of any convex polygon is always 360. We already figured out that the sum of one interior angle and its adjacent angle is going to be 180. So the exterior angle plus the interior, the adjacent interior angle, always adds up to 180. And the sum, no matter how many sides the figure has, whether it's a triangle, a square, whatever the figure, the sum is always going to be 360. The sum of the exterior angles is always 360 degrees. The sum of the measure, example 1, the sum of the measures of the interior angles of a polygon is 5 times the sum of the exterior. So, writing an equation like this, the sum of the measures of the interior angles of a polygon. Well, the sum of the measures of any of the interior angles is n minus 2 times 180. That's going to be equal to 5 times the sum of the exterior angles. The sum of the exterior angles is 360. So I've got n minus 2 times 180 equals 1800. I'm going to just divide both sides by 180 and end up with n minus 2 equals 10, n equals 12. So find the number of sides. The number of sides of that polygon was 12. Number 2, find the measure of angle B. Well, here we have B, and it shows up 3 times as an exterior angle. So if I add up those exterior angles, they're going to equal 360. I'm missing this exterior angle, so I first have to find that, knowing that the exterior plus the interior adds up to 180. So 180 minus 68 is going to give me 112 for that exterior angle. So I've got 3 B's plus 112 plus 43 plus 69, and the sum of those exteriors is always 360. That gives me 3B plus 224 equals 360. 3B equals 136. I'm going to leave this as a fraction because it's a repeating decimal. 45 and 1/3, I believe, is what I get. 12, 16. Okay, so I found out pretty fast that A was 116. A and B are same side interior, so B was 54. C and this one above it are same side interior, so C is 90. D and this one are same side interior, so D is 82. Then I started doing some formulas. We can find E and P because they are the same, so I'm going to start by calling them, and in here, this angle right here has to be 98, and then these 4 form the inside of a quadrilateral, so the sum of those has to be 360. So go ahead and find E and P. Put it on pause and find them. And hopefully you did that by going 2P plus 54 plus 98 equals 360. Came out, so P is 104, and then E also has to be 104. Now, let's see. The next easiest thing could be to work on what N is. So we know this one below N is 90, and then we've got N is a quadrilateral. Let's go ahead and figure out N. I got N to be 118. Once you know N, you can find out M, because N plus M plus 106 has got to add up to 360. So go ahead and find M. And I got M as 136. Let's see. Once you know M, then the one below it here is 90. So it's going to allow us to find what K is. This one that I've just drawn in is vertical to K, so they're going to be the same. And we've got 3 out of 4 of those in that quadrilateral. So go ahead and figure out K. Pause me. And did you get K to be 74? And then if K is 74, then this one here is also 74. So now you can figure J. J is 106. And what else do we need? We need F and G. So I'm going to go back to this pentagon. So within this pentagon, this is going to be 82. B we have was 54, so this one below it is 116. From that you can get F, because those 5 are going to add up to be 540. So put me on pause and find F. And I got F is 88. Then F plus G plus 122 has to add up to 360. So go ahead and find G. I got 150. And then this is 54. This is 90. G we said was 150. So from that we can find H. Go ahead, put me on pause, find H. And I got H is 66. And did I miss? I think we got them all. Okay, what is wrong with this picture? So all 3 of these exterior angles that are marked have to be 49. This one has to be 180 minus 135, or 45. So if we added them up, go ahead and add up your exterior angles now. 3 of them are 49, one's 45, and one is 154. I believe I got it to be 346, so something has to be wrong. Can't be, it has to add up to be 360. The sum of the exteriors are always 360.